Behind me is a classic counting problem. Here it is. Consider this 4x4 grid of squares, and this as the start point, and this as the end point. Now, on each move, we may either move only 1 unit to the right or 1 unit upwards. Never both, of course, but we can only choose between those two moves. Now, I'm going to ask you, how many different paths exist from the start point to the end point where we make exactly 5 turns? And by turns, I mean when we change directions. So, for instance, in this path, which I've highlighted, which I've labeled with arrows, we make exactly 5 turns because this over here is our first turn where we move from horizontal to vertical, and our second turn, third turn, fourth turn, fifth turn. So this is a valid path. How many such paths exist? Firstly, this problem might not be so easy on its own. So let's first try to extract some basic information. And that is always a key problem-solving strategy. When you are faced with a challenging problem, always look for some basic information to help you. So we see that no matter how arbitrary your path may look, it's always going to be the case that you will have always traveled 4 units to the right and 4 units upward, no matter what, right? Because in order to get the start to end, you have to travel a total of 4 units to the right and 4 units upward. So we see that the total path length is 8. And plus, we must have the total number of moves to the right to be 4 and total number of moves upwards to be 4. Now, we see that when we make exactly 5 turns, such as this path, we see that the number of horizontal movements will always be 3. There are 3 horizontal movements. 1, 2, 3. 3 times. So this will actually be true for any path that takes exactly 5 turns if we start out horizontally. I'm going to denote each horizontal movement as H1, H2, H3, where H1, H2, H3 is the number of units we move on each of these horizontal movements. Now we know that the number of units horizontally to the right must always add up to 4. So the sum of these must be 4. Furthermore, we see that in a path that takes exactly 5 turns, the number of vertical movements here is also 3. There are 3 vertical movements. And we know that the sum of those vertical movements must also sum to 4. So we just need to basically calculate the number of positive integer solutions of h1, h2, h3 that satisfy this equation, and similarly for v1, v2, v3. And that's going to basically correspond to the number of ways we can move horizontally, the number of combinations we can move horizontally, and the number of combinations we can move vertically. If we multiply them together, we get a path, and that's the number of possible paths. So how do we count the number of positive integer solutions to an equation like this? Well, there is one very nice trick we can do. First, consider 4 as 4 dots, okay? 4 dots, items, bowling balls, whatever you want. Now, in order to basically find solutions to this equation, this is equivalent to basically placing bars within these gaps. And you see that they divide the balls into 3 groups. So for instance, this one will correspond to H1 being 2, this one will correspond to H2 being 1, and H3 being 1. And the sum of H1, H2, H3 will sum to 4 balls or items. So we see that the number of positive integer solutions to this equation is just how many ways can you put in bars within these gaps? Well, there are 3 gaps, right? And we need to choose 2 places to put the bars. So the number of positive integer solutions is 3 choose 2. And so there are 3 positive integer solutions to this equation. Furthermore, it's the same with this. It's the exact same case, 3 choose 2. So we just need to multiply these 2 together. 3 times 3, that will be 9. So is 9 our answer? No, because we've only dealt with the case where the horizontal move is the first move. What if the vertical move was the first move? What if we first moved 2 units vertically? Well, that is actually very easy to deal with, because for every single move where we start out horizontally, there is a corresponding symmetrical move where we first move vertically. So this singular path over here, there's a corresponding path where we first move vertically. And it's also symmetric to this. So all we need to do is multiply this 9 by 2, because just double it, right? So 2 times 9, we all know what that is. It's 18. So the answer is actually 18. There are 18 such paths from the start to end that take exactly 5 turns. And that's our answer. Being able to solve these problems is really cool, and I hope you found this video very interesting. If you did find this video interesting, then please do consider dropping a like and subscribing. Thank you very much. Bye.